And here we have the second force problem without inclines or friction, and we've included a pulley system here. So if we look at this diagram, it's basically asking, when released, what is the acceleration of box A and the tension in the rope? And here we have box A, which weighs 9 kilograms, that's on a frictionless surface, and here's our pulley. And then off the edge of whatever table or surface that friction A is on, hanging off of that pulley system is box B, which weighs 12 kilograms. Alright, so first off, we want to draw our free body diagrams for both of these boxes because they're going to be different. So for box A, because it's on a surface, there's definitely going to be a normal force, and there's always going to be a gravitational force. And then we also have the tension force, which pulls the box this way, towards the right. And then for box B, it's just hanging in midair, so there's not going to be a normal force, but it's going to have the same tension force. Oops, going to make that around the same length. And then there's a gravitational force. And then we can just use our intuition to figure out that the boxes are going to move this way, right? So box A is going to move towards the right, and box B is going to move downwards. Alright, so we're going to be using Newton's second law. If you remember what that is, it's F net equals ma. And box A and box B are going to have different net forces. So for box A, F net A equals mass of A times acceleration of A. And if we look back here at box A, the normal force and gravitational force are just going to balance each other out because there is no acceleration in the vertical direction. And that means that the only force that's really making an impact on box A's acceleration is going to be the tension force. So we can replace net force of A with tension force, and then we know that it weighs 9 kilograms. But we also do not know the acceleration of A. And if we move on to box B, we can make the same starting equation, but replace our variables. And then if we look here, there are only two forces acting against it, and because it's moving down, our net force is going to be gravitational force minus tension force equals mass of B times A, acceleration of B. And we explained that in the previous forces problem video. Anyways, gravitational force would just be 12 kilograms times gravity minus tension force equals to 12 times AB. And then the thing is these two boxes have the same acceleration, just in different directions. And the tension forces acting on them are the same because it's the same rope. So technically there is no differentiation between acceleration of A and acceleration of B. They're just equal to each other. So technically we can plug this into here. And then our result would be 12 times 9.8 minus 9A equals 12A. And if we solve for A, we are going to get 5.6 meters per second squared. And then the tension force is going to be pretty easy, right? We just have to plug A back in that equation, and then our tension force is 50.4 newtons. And there you go. You solved pulleys.